Okay, we're finishing up acceleration and then we'll go to velocity and acceleration in terms of position. So here we have a vertical position above the ground of a parachutist. T seconds after opening the parachute is given by S of t. According to a simplified model, the acceleration of the parachutist is 30 e to the negative 2t. Assuming the velocity of the parachutist is negative 20 meters per second squared, that should be meters per second. When she opens the parachute, find her speed after 1 second. So, first thing we do, we have acceleration. To get to velocity, we need to integrate. So, that means integral of 30 e to the negative 2t dt. So, in order to integrate, e to the negative 2t is e to the negative 2t. The 30 can stay. But the chain rule here says, normally I would multiply by negative 2, the derivative of the exponent. So to reverse the chain rule integration, I'm going to divide by 2, and I have a plus c. So that gives me negative 15 e to the negative 2t plus c is v of t. That's my velocity function. I know v of 0. It tells me that's negative 20. That's my initial velocity. So I need to plug that in. And I got my plus c there. So negative 20, e to the negative 2 times 0 is 0. E to the 0 is 1. This is a case, make sure you plug it in. Don't just assume that c is the initial velocity, even though it often is. Find her speed after 1 second. So now I need v of 1. Negative 15 e to the negative 2 times 1 plus 5. And I grab a calculator and I just stick that in. It's not plus 5, it's minus 5. And I get v of 1 equals negative 7.03 second. No, it's a velocity, it's not seconds, it's meters per second. Okay, the next question. If the parachute just opens the parachute at an altitude of 1,000 meters, how long does it take her to reach the ground? At what vertical speed will she reach the ground? So, next part I need to do. So I'm going to write my v of t equation here. Because I'm going to need to get it to get a displacement equation. So I will integrate my velocity equation. And I will divide, same process for integrating here. So The negatives cancel. I get 15 over 2 is 7.5. And I'm told S of 0 is 1,000. So the initial height is 1,000. This whole initial term is 7.5. This is 0. So I subtract 7.5 and I get 992.5 equals C. So my S of t equation equals 7.5 e to the negative 2t minus 5t plus 992.5. If I want to know when it equals the ground, I'm gonna set it equal to 0 because ground level is going to be 0. I don't feel like solving it by hand, so I'm going to solve by graphing. Keep in mind that it will take a while for this to hit the ground, so I will need to make an appropriate window. So let's just pull it up on the calculator here. I guess I can clear this out. And I'm going to clear off my screen. Point 5 E. Make sure to use X, not T. Now this is not on my screen at all, and it won't be there with a standard zoom. I am looking for when it equals 0, so I don't need to make it a ton, but I'm going to adjust my window. 0. I'm expecting it to get down within 300 seconds. It will take a while though. It's several minutes once you pull a parachute. Negative 100. They pull it at 1,000, so I'm going to start with my Y max at 1,000 just so I can see it. Oh, that's a relatively constant descent. I was not expecting it to be that constant. Window, okay. Analyze graph 0, 198.5 is X or T. It also asks me for the velocity. So my V of T equation, so I'm just doing V of 198.5, which was negative 15 e to the negative 2 times 198.5 minus 5. When I plug that into a calculator, I get negative 5. e to this large of a number in the negative direction is basically zero. So my parachutist will hit the ground at -5 meters per second, or going 5 meters per second down. What is the last piece of the question? How long after opening the parachute will her speed be 6 meters per second? So, oh, last thing about the graph. If you solve by graphing, you need to draw out your graph, label your axes, and an absolute must for credit is putting that point on the graph. All right, last one. Last question asks us, when will it reach 6 seconds? Or 6 meters per second since it's down. I'm going to be using -6. If you try to use +6, it's not going to have any solutions. And I will solve by graphing again. For time's sake, I'm not going to show it. I think you can solve by graphing. I get 1.35 seconds. Okay, example 5. Feel free to watch these videos. I'm sure they're interesting. So, okay, it says at t seconds, the acceleration of a particle is given by 3t I hat plus cosine t j hat meters per second squared. Its initial velocity is 3i plus 2j. Find the velocity function of the particle. So we have to integrate acceleration. And essentially with vectors in component form, I can integrate them separately. Which this would just work nicely anyways. So the integral of 3t is 3t squared over 2 minus integral of negative cosine is negative sine. The I hats and the j hats just stay as they are. And we have our plus c. So then this is v of t. I know v of 0, 3i hat plus 2j hat equals 3 times 0 squared over 2. That's I hat. So in order to do this, the I hats need to work together and the j hats. And the sine of 0 j hat plus c. So this works out to be 0 plus c equals 3 I hat plus 2 j hat. Because c here would be a vector, so it's just that. If you had to do some subtracting, you'd probably still end up with an I hat and j hat. Find the velocity function. I need to list the whole thing. I'm coming up here. Make sure anytime you're doing this, try to do it in order. I just don't have room on the screen. I guess I could write it down here. V of t equals -3t squared over 2 I hat minus sine t j hat plus 3 I hat plus 2j hat. Or here's how the book writes it. This is v of t. They're going to factor out the I hat, which I guess I think I kind of like. They factor out the I hat and the j hat. You could give it in column vector form like this. Any of those work. Okay, final example for this section. At time t, the velocity of the particle is given by this. Given the particle starts from a point where the position vector is 1, 3, find the position vector when t equals 4 seconds. So I'm going to integrate it, which really means I'm going to integrate the two parts. I don't love how they show this. Surely how I'm probably going to show it is two separate ones. So this is t cubed over 3 minus t squared over 2 plus c. It starts from 1, so s of 0 equals 1, which equals 0 cubed over 3 minus 0 squared over 2 plus c equals 1. So s of t, the first vector, this one, when I integrate it, gives me t cubed over 3 plus 2t plus c. So now s sub y, I could call this s sub x and s sub y. Make that a meter sub y. So referring to it as s in the y direction of 0 equals 3, which equals 0 cubed over 3 plus 2 times 0 plus c equals 3. No, minus 2t plus 2t. So that's my position vector. If I want s of 4, 4 cubed is 64. And I don't feel like doing the fraction by hand, so I'm just going to use the calculator, because I can. Sixteen over 2 is 8. 43 thirds. Which I guess is 11. 14 and 1/3. And then my next one, 2 times 4. And 97/3. So that is my position vector. And I should put a unit on it of meters. Um, They label it meters. The question did not give me anything about unit of meters. It's probably safe to assume it. The acceleration is then the derivative. So I just do the derivative of each column. 2t minus 1, 2t. And apparently it wants the t equals 4. I don't think that, yeah, it wants a of 4. That's not very clear. This is not a well-written question. The exam questions will be clearer than that. 2 times 4 is 8 minus 1, 8. It's 7, 8. And that is meters per second squared. Okay, that is that section. Velocity and acceleration in terms of position. This gets a little interesting. So, we know that acceleration is dv dt, or v prime, or v with a dot over it is another way of writing v prime. So, v prime, v dot, same thing. And we know that that's acceleration. But we also know that that is dv dt. However, sometimes we end up with dv ds, which means velocity relative to position. The acceleration is then dv ds times ds dt. Keep in mind ds dt is just v. So you have to keep track of what your variables actually mean. So A is equal to dv ds times v. Okay? And that will sometimes happen. Dt ds is just a reciprocal. Um, so that's 1 over v. Okay. Be careful of those relationships. So, a particle moving on a straight line with displacement s has a fixed velocity. V of s equals 1 over s. What is the acceleration when the particle's displacement from O is 2 meters? So, I want A of t. So here I have V of s. This is what I'm looking for. V of s equals s to the negative first. So when I take the derivative of V of s, I get dv no, not ds, dv ds because my independent variable is s. Times s to the negative second, negative 1, s to the negative second. dv ds is equal to dv dt times v, which equals 1 over s squared. So dv dt, or the acceleration, equals, so now I'm going to divide by v, 1 over s squared times 1 over v. V is 1 over s, so 1 over 1 over s, which is simply s over 1, which means the acceleration is 1. Hmm, they do not get the same thing I do. They multiplied the other side by ds dt. Hmm, they get 1 over negative 1 over s cubed. Oh, I did lose my negative. And they did not show this very well, so I'm not sure if they made a mistake. I'm going to show you the way of doing it Mr. Klein's way, which I think is actually a little better. You do this as if it were a related rate problem. So I've got v sub s equals 1, or s to the negative first. So I get the derivative of v dv dt equals negative 1. Since I'm doing everything relative to t, dv dt can be here. Negative 1 s to the negative 2 ds dt. ds dt is this. Yeah, I think their explanation is bad. So this is probably the easiest. Treat it as a related rate problem anytime you need time and that's not given as the independent variable. ds dt is 1 over s, so I end up with negative 1 over s cubed. And that is actually the easiest way to do that. So some of the things they show you, yeah, apply it, but because my independent variable was not this, I would just do it like I derive like I'm deriving a related rate. How long does it take the particle to move? Oh, and I need find the acceleration of the particle when it is 2 meters, a of 2, negative 1 over, I guess I have this is a of s still. This is not a of t. Because my variable is actually s. But acceleration should be thought of as dv dt. 2 cubed -1/8. Says, how long will it take the particle to move from 2 meters to 4 meters? So I'm looking for a time. So right now I have a velocity. How long will it take? I'm looking for a time, so that I can think of as a dTds, which is 1 over the velocity function, which means reciprocal, so that's just s. I will integrate my dTds function from 2 to 4. And I get s squared over 2. I plug them in. I square 4, I get 16 over 2. I square 2, I get 4 over 2, which is 8 minus 2 is 6. How long does it take the particle to move? This is a time that's 6 seconds. Okay, be careful of that. Um, so there are other approaches that can be used. For example, S prime equals V. The relationship can be written as S prime equals 1 over S. In the higher level extension, you will see methods for solving differential equations like this of the displacement function of time. You can also use Wolfram alpha to do this. Your calculator can do some of it. Okay. But that is a technique. We will get more into them with differential equations. Example 2. Particle is moving along a straight line. The acceleration of the particle is given by the function a equals -1 plus v. The initial velocity is 1 meters per second. Find the displacement between the starting position point and the position when the particle comes to rest. Okay. So I have my independent variable here is v. So I am looking for ds, which is position, in terms of v. So I'm looking for ds dv. What I'm given is dv dt. So dv dt times dt ds will give me dv ds, which is the reciprocal of ds dv. And dv dt, dt ds is I'm trying to justify how they got this there. dv dt is a. Oh, dv so I'm trying to get dsdv, which its reciprocal would be helpful, is equal to dvds times dsdt. Those would cancel and I get back to here where I started. So I can get dvds times dsdt is simply velocity. So if I want this in reverse, ds dv, I need to take dv dt as a function of velocity. They did not show this work. So I'm trying to figure out, they get it to be this. So I'm trying to get that by itself. Okay, so what they did here is we end up with the VDT equals dv dv ds dot v, or times v. dv dt is my acceleration, so I'm going to plug that in.
So. Yeah.
I will divide both sides by v
Why?
to solve for dvds.
I'll go do this one. We got it in front of me. Thank you.
You trying to all
And then I must flip it to get ds dv.
Oh, I forgot my phone to go again. I was relying with like that school. It was hard to model in this thing.
Says the initial velocity is 1 meter per second. So
Funny. Yeah.
I'm taking the integral from 1 to 0 of this.
I mean,
Says
pretty good.
the initial velocity is 1 meter per second. So that's where I start, and it wants to find how far it goes when it comes to rest. So 1 is the start, 0 is the end. And these are velocities, these are not positions or times. To integrate this,
You know, right.
I will use a calculator. I believe this uses integration by parts, which you don't have to know. So we will go to the calculator. I'm going to erase some of this. Yes. Menu. calculus, numerical integral, 1, 0.
Absolutely.
I'll just put the negative on top.
This one, you look. This is pretty error.
And I get 0.0306 or 07. And that is my answer.
Oh, man.
Do the integral on your calculator. Write out this as work and make sure to get it in there. The question asked, find the displacement. This would be in meters. Okay, one more example. So a particle is moving along a straight line with s measured here. Find the velocity of the particle in terms of s. So
Easy.
I'm just going to do this like it's implicit or like it's related rates. 3s squared ds dt. This velocity is ds dt times 1 ds dt minus 1 dt dt equals 0. dt dt is not needed. I will solve for ds dt, which I will start by adding 1 to both sides, and I will factor out a ds dt. Then left with 1, wait. Equals 1. I will now divide by my set of parentheses.
I pledge allegiance to the flag of the United States of America.
So ds dt, which is v, will be equal to 1 over 3s squared plus 1. This is in terms of s because that's my s is my independent variable there. So the next thing it asks is to find the acceleration of the particle, which means find the derivative of this, which for simplicity, I'm going to call it this. 3s squared plus 1 to the negative 1. So then I'll take the derivative dv dt equals negative 1, 3s squared plus 1 to the negative 2. Now I got to do the chain rule part. 6s ds dt, which is v. So this comes out to be negative 6s times v over 3s squared plus 1 to the negative 2. I need to substitute v back in. So negative 6s times 1 over 3s squared plus 1 over 3s squared plus 1 squared That's over 1. This can become, the top is negative 6s over 3s squared plus 1. The bottom, when I multiply by the reciprocal, 3s squared plus 1 squared. So I end up with negative 6s over 3s squared plus 1 cubed. Okay, it's important to treat these like related rates or implicit type derivatives because your independent variable is not always the dt that you need for acceleration and velocity. That is the end of 5.13.
I think so, yeah.